All right, y'all, welcome to drill 3. It's a multiple choice. We're just going to go right on through and answer these as we go. So starting with number 1, what is the number of protons, electrons, and neutrons in boron 11? You should be able to figure this one out pretty easily. Boron is atomic number 5, and they have not mentioned that this is charged in any way, shape, or form. So we're going to say 5 protons, 5 electrons. So it's going to be one of these 3 answers. Moving on, the 11 represents mass number. So 11 minus 5 is 6. 6 neutrons, the answer is C. Moving on to number 2, what is the number of protons, electrons, and neutrons in sulfur? But now we have all these numbers around. So we see that we have 16 protons because sulfur is element 16, but also denotes it right there. We see that the mass number is 34. So if we take 34 and subtract 16 from that, we get 18. And then we notice that we have a 2 minus charge. So we know we have 16 protons, 18 neutrons, and then our protons plus our electrons ends up with a charge of 2 minus. So that means we have 2 more electrons than protons. So we also have 18 electrons. Then we just have to find the answer with that. And looks like we are at C again. All right, moving on to number 3. Which statement about the isotopes of chlorine 35 and chlorine 37 are correct? Well, isotopes have the same chemical properties. They definitely have the same atomic number because they're both chlorine. They don't have the same physical properties, so we're just going to go ahead and find the answer that says 1 and 2. That's going to be A. All right, moving on to number 4. A sample of element X contains 69% of X63 and 31% of X65. What is the relative atomic mass? Now, you're not going to have a calculator, so you're going to have to try and figure this one out, but it's pretty easy to check that if we have more of the 63 and less of the 65, it's going to be somewhere closer to 63. So we're going to be between 63 and 65, but because we have more of the 63% sample, we're going to be here, closer to 63. It's not going to be exactly 63, it's not going to be exactly 65, and it definitely won't be more. So it's going to be B, 63.6. All right, moving on to the relative atomic mass of an element with a mass spectrum shown in figure 17. Well, we see that we have 80% of the 23, and 20% of the 28. That means that we're going to be closer to 23. And actually, this is split up in percentages that equal about 1/5 for each individual percentage. So we're going to be closer. We're going to be 24. If we actually did the math, it would be 23, or sorry, it would be 23 times 0.8 plus 28 times 0.2. But just looking at this problem as a whole, we can see that if 4/5 of it is closer to the 23, we can just go and say it's right here at 24. Moving on to number 6. This one's tricky because it's going to play off the fact that you may not read it right away properly. We're comparing energy, wavelength, or frequency. So remember, a high energy is going to be the same as a high frequency, which is going to be the same as a short wavelength. So we have to compare all these terms. So as we go through, we know that UV is going to be represented by high energy, infrared as low energy. So A says high energy and short wavelength. That's true. While infrared says low energy and low frequency. So as we compare these, we can see that A already is correct. It is our answer. Just to go through and make sure, B says high energy, low frequency. That contradicts each other. C says high frequency, short wavelength. That's good, but infrared is not high energy. And then D says high frequency, long wavelength. Also contradictory, so it's got to be A. All right, lastly, number 7, in the emission spectrum of hydrogen, which electronic transition would produce a line in the visible region of the electromagnetic spectrum? Unfortunately, you just will have to memorize this type of answer, but usually in hydrogen, when you go from N equals pretty much anything greater than 2 to n equals 2. Sorry, let me rewrite this. When n is greater than 2 to n equals 2, you get spectrum in the Balmer series. And that is going to be our visible. So the only one that goes to n equals 2 is B. So it's going to be B. And that is the answer to all of these.